Yes, we were discussing about the null hypothesis, and there can be two decisions which is related to the null hypothesis. One is reject, another is do not reject. So these are the decisions we are going to take after testing the hypothesis. How we are going to test? We are going to use the statistical methods, and we'll be learning about we'll be learning about two statistical testing. One is t-test and another is ANOVA. Okay, so first we will try to understand what is null and alternative hypothesis. Okay, what is null hypothesis and alternative hypothesis? I'll just show you. So we have discussed in the last page, that is hypothesis testing problems. First of all, we identify the claim or statement to be tested and write it symbolical form, right? On whatever claim you wanted to do, we'll be writing in the symbolical form. Mu equal to 0, mu1 equal to mu2, something like that, symbolical form. After that, we write the complement or opposite of the claim or statement in symbolic form. So in our example, this motorcycle example, what is our motorcycle example? In our motorcycle example, mu equal to 60 kilometer per liter. Okay, then its complement will be okay. What is given in the first example? Mu is 60 kilometer per liter. Okay, what is complement of this? So complement of this is mu is not equal to 60 kilometer per liter. So we are writing the two statement. One is we can P and Q are known as prepositions. Its truth value is to be tested. So mu equal to 60. Its complement is mu is not equal to 60 kilometer per liter. And the second example what we have seen is mu is greater than 200 grams. That banana example, right? Mu is greater than 200 grams and its complement will be, what is its complement? Mu is lesser than 200 grams, lesser than or equal to 200 grams, right? See this banana example. Okay, mu is greater than 200 grams. Its complement is mu is lesser than or equal to 200 grams. Right? Mu is less than or equal to 200 grams. And then if mu is, suppose mu is greater than 200 grams, then it's opposite. Suppose I'm telling that mu is lesser than 200 grams. Okay, suppose I'm claiming mu is lesser than 200 grams. Okay, what will be complement of this? Mu is greater than or equal to 200 grams. Right? So this is how we write the complement. The claim and its complement are formed in such a way that they cover all possibility of the value of the population parameter. This is all possible values. Okay, and nothing is left. So a number can be lesser than or it may be greater than or equal to. Is there anything left in between? No. So we are taking all possible values, a complete. You can call it as complete. So mu cannot take any other value. Either it should be lesser than 200 or it can be greater than or equal to 200. So anything else, we are not leaving anything. So if I'm using the real line, okay, if I'm using the real line, suppose this is my 200. Lesser than 200 means all these values which are lesser than 200. Greater than or equal to means including 200. I include 200 in greater than or equal to. So including 200 and all these values, the whole real line is covered. So none is left. right? So this is the all possible values. So you can call it as complete. Okay, I'm taking all possible values. So mu is greater than 200 or mu is less than or equal to 200. In another case, mu is less than 200 means its complement will be mu greater than or equal to 200. The claim and its complement are formed in such a way that they cover all possibility of the value of the population parameter. Once the claim and its complement have been established, then we decide that these two, which is the null hypothesis and which one is alternative hypothesis. Now we have to think which is null hypothesis and which is alternative hypothesis. The thumb rule is that the statement containing equality is the null hypothesis. What is null hypothesis? The statement Okay, null hypothesis is nothing but a statement containing equality is the null hypothesis. Okay, the statement which is having equality is known as the null hypothesis. That is the hypothesis which contains so we can say the hypothesis which contains the symbols what are the symbols equal to or okay it may have the symbol equal to or it may be having the simple symbol lesser than or equal to or it may be having the symbol greater than or equal to is taken as null hypothesis. All these are taken as null hypothesis. Okay. The symbol which is having equal to sign, lesser than or equal to sign, greater than or equal to sign. So what are all null hypothesis here? This is null hypothesis which is equal to sign. Lesser than or equal to sign is the null hypothesis. Here greater than or equal to sign is there. So all these are null hypothesis. So you should have these signs equal to, greater than or equal to or lesser than or equal to. All these signs are there. That particular thing we are calling it as null hypothesis. And whatever is the converse of this statement. So that converse of this statement is treated as alternative hypothesis. Right? So the what are alternative hypothesis I can say? What is alternative hypothesis? I can say the converse of null hypothesis. Okay, the converse statement of null hypothesis is known as the alternative hypothesis. Can you say the converse statement of the previous one? Okay, what is equal to's converse? What is the equal to's converse? Will be not equal to, right? Equal to's converse is not equal to, right? What is greater than or equal to's converse? Okay, what is converse of greater than or equal to? It is lesser, sorry, what is the converse of lesser than or equal to? It is greater than. Okay, converse of greater than or equal to will be less than, will be less than symbol, right? And this will be greater than symbol. So these two converse, these are known as this is null hypothesis, this is alternative hypothesis, right? And now how to denote it? Next is how to denote it. H naught. Okay, we denote null hypothesis by H naught. And we denote alternative hypothesis by H1 or HA. This is how I denote the alternative hypothesis, right? How to denote the alternative hypothesis? H1 or HA. How to denote the null hypothesis? Always we denote it by H naught. This 0 represents null. Okay, this 0 represents null. Right? H naught. That is why we are calling it as H naught. So, in our motorcycle example, mu equal to 60 kilometer per hour. Per liter, no? Mu is 60 kilometer per liter is the null hypothesis. So what will be the alternative hypothesis of this? Mu is not equal to 60 kilometer per liter. Okay, this will be my alternative hypothesis. So this will be my H naught and this will be my H1. Right? This is how we write the null and alternative hypothesis. And then I will write in the form of, that is H naught such that mu equal to 60 km per hour and H1 such that mu is not equal to 60 km per hour. In the second example, if you say H naught will be mu is lesser than or equal to 200 grams. Okay, what is my H1? Mu is lesser than or equal to, we have written, no? So mu is greater than 200 grams. Okay, another example is H naught. Mu is lesser than or equal to, no, greater than or equal to 200 grams. Okay, H1 for this will be mu is lesser than 200 grams. So example 1, example 2 and example 3, right? So null hypothesis is a hypothesis which is tested for possible rejection under the assumption that it is true. So it's very important. What is the definition of null hypothesis? Ultimately we come to the definition of null hypothesis. Okay, what is the definition of null hypothesis? Which is given by the Fisher, R.A. Fisher, Professor R.A. Fisher. Null hypothesis is a hypothesis. Okay, null hypothesis is a hypothesis which is tested for possible rejection under the assumption that it is true, right? So what is null hypothesis? It is nothing but a type of hypothesis which is tested for possible rejection. We always test it for, we want to reject it, possible rejection under the assumption that it is true. So we will first assume that null hypothesis is true. After assuming the null hypothesis is true, statistically we will do all the testing and our aim is to reject the null hypothesis. That is our ultimate aim, is to reject. It's not aim, that is what we want. I cannot call it as aim because after testing we may reject or we may not reject. That is the decision we are going to take. But what will be there in our mind? We are framing the null hypothesis thinking that it should be rejected. That will be our thinking in our mind, right?